So this is a polynomial in standard form, and there's no numbers anywhere, it's just all these letters. So I've written these as variables, and we can talk about what each part of this this big ugly equation thing means. Let's do that right now, and we'll get into an example of how numbers would play into this in a bit. So I want to talk about this guy right here. This is an important term that we call the power function. There's another name for it too. It's called the leading term. And we call it the leading term because it is the term which leads the polynomial, right? It's all the way to the left. All these other things are also terms, but none of them are leading because their power of x, their exponent, is smaller than the leading term. If you notice, the leading term's exponent is n, but all the other ones have an exponent that's lower than that, maybe n minus 1, n minus 2, all the way down to 1, or this guy over here has the smallest exponent. That's just 0, x to the 0th power. Okay, so that's what terms mean, and that's what the leading term is. Now, since this is the leading term, if I asked you for the leading coefficient, you should point to this guy right here, this a right here. This is the leading coefficient. Remember, the coefficient is just the number which is in front of x, and here we're assuming that a is a number. So the leading coefficient is the number that's all the way to the left, and this right here we could call the trailing coefficient. No one calls it the trailing coefficient. Everyone just calls it the constant. For whatever reason, that's the name that this guy got when they were handing out math names. One more thing, these exponents in this polynomial here, those are called degree, okay, or degrees. So the degree of this term right here would be n minus 1. Okay, the degree of this term right here would be n. And when you talk about the degree of a polynomial, the degree of a polynomial is simply the degree of the leading term. Degree of polynomial equals the degree of the leading term. So I think it's a good point now to get into an example that has more numbers on it so we can get a handle of this. So right here I have this polynomial, negative 8x cubed minus 5x to the 6th plus 5x to the 5th plus 7x plus 1. And you should be able to see that this is not in standard form, even though it looks a lot like that one up there. But I want to point out something here. Do you see this exponent right there? It's 6, which is the biggest exponent anywhere, but it's not all the way on the left. If you're going to have a polynomial in standard form, your numbers in the exponents have to start high and march down. N minus 1, n minus 2, n minus 3, and so on. Okay, this one, it's all over the place, right? 3, 6, 5, 1. So this is not in standard form. Let's write it in standard form, and then we'll start talking about it a bit more. So the biggest exponent is 6. So we put that term up front, negative 5x to the 6th. Then you have 6x to the 5th. Then you have negative 8x cubed plus 7x plus 1. Okay, now we're in standard form, 6, 5, 3, 1, 0. And it is okay that some terms are missing. Like, where's the x squared term? There is no x squared term. Or you could think about it as there is an x squared term, but the coefficient is 0, right? It's 0x squared. Either way you want to think about it is fine. We now have this polynomial in standard form, and we can start saying things about it. So I would say my leading coefficient, or you know what, let's start with the leading term. Leading term is negative 5x to the 6th. It's just whichever term has the biggest exponent. And remember, this is also called the power function. We'll be using power functions a lot in this unit. The constant, right, that's the one with no x attached to it. That's just the number 1. And what's the degree of this polynomial? Right, we see a lot of degrees here. There's exponents all over the place, but the highest exponent is 6. So we say that this polynomial is a degree 6. Okay?